7.4, we're going to be solving trig equations. So before we get into example 1, a couple of things that we want to remember from what we did yesterday. Sine tells us to look at what? The x or the y? The y, awesome. And cosine tells us the x. And what about tangent? Y over x. Tangent is y over x. So we're going to use that today in a little bit of a different way than we did yesterday. We're going to be solving our trig equations. So the first step that you always want to do is isolate the trig function. We want to get the trig function all by itself. So it already is all by itself here. Once it's all by itself, since it's sine, we want to see where on our unit circle does the y value equal 1/2. So I'm going to go to my unit circle here. Where do we have a y value of 1/2?
150 degrees. Oh, wait. 30 degrees. 150.
30 degrees and 150. So there's 2 spots. So we're going to use the radians, not the degrees. So we're going to say theta equals, at 30 degrees, that is pi over 6. So pi over 6. And at 150, our radian is 5 pi over 6. So we have 2 answers here, pi over 6 and 5 pi over 6. Most of the time when you do these questions, you're going to end up with 2 answers. So always look at every option on the unit circle and find the ones that match. So you're looking for where you have a y value of 1/2. Could I have said 210 degrees? Does this match? No, because that's negative 1/2. So it also has to be the correct sign as well. So we're just looking for positive 1/2. All right, on the next page, we have tangent equals 2. Now tangent, we got to do a little bit more math because tangent is y over x. So I want to see where do I have a y over x value that equals 2. And we can't just look right off the bat like we can with either just x or just y. We got to do a little bit of figuring out what y over x is. So I'm going to start in my first quadrant because whatever it is in my first quadrant, it repeats in all the other quadrants. So our y over x for 30 degrees would be 1/2 over square root 3 over 2. What do we do when we have a fraction and a fraction? Keep, change, flip. So keep the 1/2, change multiplication, flip to 2 over square root 3. So this would simplify to 1 over square root 3. Is that what we're looking for? No, we need it to equal 2. Let's do the same thing for 45 degrees.
Wouldn't it be 2 square root 3?
No, because the 2's cancel because we had a 2 on the top and the bottom. So we have 2 square root 2 over 2 over square root 2 over 2. Keep the top, change the multiplication. We'll flip the bottom to 2 over square root 2, which equals 1. Is this what we were looking for? Nope. Let's do the same thing with 60 degrees. We have square root 3 over 2, our y over the x, which is 1/2. When we keep, change, flip, that would be 2 over 1. So 2's cancel. We just get square root 3. Do any of these match 2? No. You could also try at 90 degrees. Y over x would be 1 over 0, so that doesn't work. At pi or 180 degrees, y over x would be 0 over negative 1, doesn't work. Negative 1 over 0 doesn't work. 0 over 1 doesn't work. So if nowhere works, your answer would be no solution. Now we only tried the first quadrant here. We didn't have to try the rest of them because the values just repeat in every quadrant. So if it didn't work in the first one, it's not going to work in the other ones too because it's going to be the same pattern. You'll have your 1 over square root 3, 1, and square root 3, but just different signs in each quadrant. Let's look at example 5. So starting with A, first thing we want to do is isolate our trig function. How would I get the sign all by itself here? Add 1 to move it to the other side. So 2 sine of theta equals 1. Then what do we have to do? Divide by 2. So sine of theta equals 1/2. Sine tells us we look at what? The x or the y? The y. So where do we have a y value of 1/2 on the unit circle? Awesome. What are the radians? Perfect. So we have our y value of 1/2 at pi over 6 and 5 pi over 6. Any questions there? Let's do B. How can we get the tangent all by itself? Add 3 to move it to the other side. So we have tangent squared theta equals 3. How can I get rid of the squared? Square root, perfect. And what do we have to remember to do when we take the square root of both sides? Plus or minus, perfect. So this is plus or minus square root 3. Now tangent tells us we look for what on the unit circle? Y over x. So we have to do a little bit more math than just looking at our x's and our y's. We want to put y over x and see what matches square root 3. We just did this on the last unit circle, so I already know that it's going to be pi over 3, but let's just test it just to be sure. Our y over x would be square root 3 over 2 over 1/2. What do we do when we have a fraction and a fraction? Keep, change, flip. Keep the top, change multiplication, flip the bottoms, 2 over 1. 2's cancel, we get square root 3. So does this work? Yeah, because we're looking for positive or negative square root 3. Now, you can test every single point on your unit circle, but a little trick is if it's pi over 3, whatever your denominator is, your other answers are going to have that same denominator. So if pi over 3 works, that means 2 pi over 3, 4 pi over 3, and 5 pi over 3 are probably going to work here too. We just have to check the signs, but since our answer could be positive or negative square root 3, they're all going to work. But just to be sure, you can test it out. So at 2 pi over 3, our y over x would be square root 3 over 2 over negative 1/2. When we keep, change, flip, we get negative square root 3. Does it work? Yeah. So 2 pi over 3 works. Y over x for 4 pi over 3 would be negative square root 3 over 2 over negative 1/2. When we keep, change, flip, does it work? Yeah, we get positive square root 3, so it works there too. And then let's just test 5 pi over 3. So negative square root 3 over 2 over 1/2. Keep, change, flip. We get negative square root 3. Can it be negative square root 3? Yeah, we said it could be positive or negative. So all 4 of these work as answers. So theta can equal pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So you always want to look for, especially when it's tangent, you always want to look in the first quadrant. Whatever matches, it's going to have the same denominator in your other answers. So because pi over 3 worked, we looked for other denominators that have 3. So because this answer was plus or minus square root 3, so it could be positive or negative, all 4 of them actually work. If it was just positive square root 3, we'd want to see which ones were positive, which would be like pi over 3 and 4 pi over 3. All right, let's look at example 6. So example 6, we have a cosine squared and a cosine. So we can't combine these because they're not like terms. You can't add a cosine to a cosine squared. So we can't isolate our trig function. But we need to think, if our cosine were x's, this would be in the form of 2x squared minus 7x plus 3. How would I solve something like this? Factor. We would factor. How would we factor this? Multiply the first times the last. So 2 times 3 would be 6. What are 2 factors of 6 that add to negative 7? Negative 6 and negative 1? They multiply to be positive 6 and add to negative 7. So instead of saying x minus 6 and x minus 1, we're going to say cosine theta minus 6 and cosine theta minus 1. Now we can't forget, if we started with multiplying, what do we have to remember to do? Divide by the 2. So divide by whatever your first number is. Whatever you multiplied to the last, that's what we got to divide by. So this will be cosine theta minus 3 and 2 cosine theta minus 1. Now we're still solving, so we want to set both of these equal to 0. So when we solve them and we isolate our trig function, we get cosine theta equals 3 and cosine theta equals 1/2. Now from here, we're going to look at the unit circle. Cosine tells us to look at what on the unit circle? The x value. So I want to see where on my unit circle do I have an x value of 3. So if we look at all of our x values, anywhere do we have an x value of 3? No. So this one doesn't give us a solution. It's not that it's no solution, because we still have another answer. We still have the other half of this, but this one just doesn't work out to be anything. Let's try for cosine of theta equals 1/2. Cosine tells us we look at what? The x. So I want to see, where do I have an x value on my unit circle that equals 1/2? Where do you think? What's our radians? Pi over 3, so that works. Anywhere else? 5 pi over 3. So 300 degrees, but we want the radian, so that would be 5 pi over 3. So that would be our 2 answers. So it's not that it's no solution, because we still have a solution, but just this part of the question, the first part, didn't give us an answer, so we just had to use the solution from the second part. In example 7, the directions kind of give it away of what we need to do. It says to factor. How would I factor something like this? If we look at each term, because terms are separated by a plus or minus, do the terms have anything in common? Cosine. So they have a GCF of cosine. We're going to take out our GCF. What do we have left when we pull out the GCF? 5 sine theta plus 4. Awesome. So once we factor, we can just set them each equal to 0. So cosine theta equals 0. 5 times sine theta plus 4 equals 0. So when I solve this one, we get sine of theta equals what? Perfect, -4/5. All right, let's look for these on our unit circle. Cosine tells us we look at what? The x. Where do we have an x value on our unit circle that equals 0? What's the radian? Pi over 2, so theta equals pi over 2. Anywhere else? 3 pi over 2, perfect. So there's 2 answers. Let's go to the second part now and see if we can find any more. So sine of theta equals -4/5. Sine tells us we look at the x or the y? The y. Where on our unit circle do we have a y value of -4/5? Nowhere. So this one doesn't give us an answer. So it's not that it's no solution, because we still had 2 other solutions, just that part doesn't give us an answer. So we talked about sine, cosine, and tangent, but you'll also have your reciprocal functions. So let's say we had secant theta equals 2. Secant is the reciprocal function of which trig function? Cosine. So I'm going to flip secant to be cosine, but if I flip the left side, I also have to flip the right side. So I'm going to flip 2 to be what? Not -2. We're not flipping the sign. 1/2. Perfect. So if you get a reciprocal function like secant, so secant goes with cosine. If this were Cosecant, what does cosecant go with? Sine. And then what about cotangent? Tangent. So if you get one of your reciprocal functions, so secant, cosecant, cotangent, you just want to flip it into one of the three main trig functions, so sine, cosine, or tangent, but you also have to flip the number that it equals as well. So it got flip both sides.